Okay, hello friends. I think we should get started. So today is day 4, right? On first 2 days of machine learning cloud session, what did we discuss? We discussed about auto ML. We discussed about auto ML, and within auto ML, we spoke about what are the various aspects which get automated. What are the various things which people will automate? Or what are the various things which are rather automated in auto ML? And then we have also discussed that we have open source tools and we have cloud-based tools. When it comes to open source, we thought about understanding teapot and the finer nuances of teapot. What we also intend to do is we are going to build a model and we are also going to deploy the model. Right? And what we have also spoken about is how teapot helps you come up with the best pipeline possible. The best pipeline, in some sense, it is the best machine learning pipeline, if I were to term it in that. It's the best machine learning pipeline. Once we are done with this, we shall talk about something called as feature tools. With that, we would have completed the open source auto ML libraries or tools, however you want to call that. Post that, we shall get into cloud and we'll look at the auto ML capabilities. With respect to Amazon, we have something called as Amazon SageMaker Autopilot. We'll look at Microsoft Azure Machine Learning Studio. And then we shall also look at Google Cloud Platform Auto ML. After we explore all of these, wherein you'll also understand how to build the model automatically without writing even a single line of code. How do you use drag and drop functionalities and yet build an amazing model? That is what we will learn when we get into cloud. But while all these pipelines are automatically built, for you to understand what is happening behind the scenes, it makes sense for us to understand the open source tools. Hence, first we are trying to understand the open source tools, which is teapot, and this is being discussed now. And we have gotten into the practical aspects. Post that, we will get into feature tools. Okay, we'll also understand feature tools. Then we'll jump into all these. And finally, after all these things are completed, we should also talk about something called as explainable AI. How explainability is being built into the models. So that is all that we are going to do. All right. So let's get into teapot and let's continue from where we have left as part of the previous module. And also, friends, on a daily basis, there will be one question which will be posted on LinkedIn. While you are watching this video and while you are trying to understand, try to also take this poll question. It will hardly take 1 minute to answer. And when you do that, you're kind of trying to recollect what you have learned. That way you'll remember a lot. No, sir. So let me get into the teapot. So yesterday, as part of this code, what we have understood is how do you connect your GPU machine? You need to go to runtime, click on change runtime. In this drop down, when it comes to hardware accelerator, you select GPU. Job done. Your GPU will be connected. Right? But the moment you select, it will not connect. You'll have to click on connect. So let it connect. It is initializing now. Sorry about that. Yep, so this hardware got initialized now. And we need to install teapot library, obviously. And this is the function to install. Then you can check the version. We invoked teapot classifier. After this, we will also look at teapot regressor. Then you load the digits, meaning this is a data set of handwritten digits. And we have yesterday also run the teapot classifier. It has run or completed 32% of different pipelines. And then it has selected this as a best pipeline. Then we loaded our drive. We exported the pipeline. Okay. We saved it in some sense. Then when we have looked at this Python code, we found that these are the different libraries which have to be invoked, and this is the pipeline which has to be used. We also get the best model from the final estimator. You take the best model, you see what is that best model, and here we are just taking the 11th image, 11th observation, and we want to see how that image looks like. This is how it looks like. This is how it looks like. And that's also 1, right? So actual image is 1. Now, using joblib, you try to, even before the joblib, you take this best pipeline, okay, this exported pipeline, the best pipeline, and then you build a prediction model, and you predict on the 11th observation, which is 1. And the predicted value is also turning out to be 1. So actual value is 1, predicted value is 1. They both are the same. Then you are importing this joblib library. Let me remove it from here. And it makes sense for me to introduce this library here. Okay. And then you have dumped this particular model, this particular pipeline, which is the best, onto your drive, Google Drive, because we are using Google Colab. You can also save it onto your local computer, okay, in the name of digits_model.pk. This is called as pickle file. Until here, we have discussed yesterday. And today, we are going to take this discussion to the next level altogether. Okay, and we are going to talk about a different use case, and then we will solve it. So we are going to apply teapot algorithm to automatically identify the machine learning pipeline. Okay, to automatically identify the machine learning pipeline, we are going to use teapot. Okay, and here in this specific data set, it's called as fish.csv. Okay, in this, we need to predict the weight of the fish. We need to predict the weight. That's the problem that we will solve. Predict the weight of fish. So we will understand how to load this data set, how to prepare the data set for our machine learning purpose, and then we will build the best pipeline. Why should we visualize load, visualize and prepare the data set? Because those aspects cannot be automated using Teapot. Right? So taking the data set and loading the data set, performing some kind of visualization, and then performing data cleansing or data preparation is something that you need to manually perform. Teapot cannot do it for you. So you manually perform that, and rest of the things we can automatically do it. So we have all these different library strengths in Python. Python has a bunch of libraries. Let me quickly write a few here. You will have something called as NumPy, which is a Python library. And NumPy is used for numerical calculations. I'm assuming that you guys are aware of a few things. If you use your regular calculator, whatever operations are performed on that calculator can be performed using NumPy. Then you have something else which is called as SciPy. This has a lot of functions which perform scientific calculations. Then you have Pandas. Pandas performs data manipulation techniques. Okay. Then you have something called as scikit-learn or sklearn. Sklearn or scikit. Scikit-learn, right? This is machine learning library. It contains all the machine learning algorithms. And then we also have something called as matplotlib. Matplotlib, which is used for data visualization purpose. Then you have something else which is called as Seaborn. Seaborn contains advanced data visualization. So these are the various libraries in which you'll have a lot of code which someone else has written in the past. We will just try to, call the relevant modules and we'll try to reuse them. And by the way, friends, we also are going to conduct free Python programming training, which starts right from the basics, right from scratch. And it is completely going to be aligned with, BTech in data science and BTech in artificial intelligence, which is launched by AICTE, All India Council of Technical Education. All these universities fall under AICTE, right? So that is what we are doing. Feel free to subscribe to our YouTube channel, and then you'll have access to that. Okay. So I'll not delve deep because I'm assuming that you have some knowledge about Python programming, right? If you don't have, we are going to certainly help you. Okay. There we are conducting free modules after machine learning on cloud is completed. We'll get started with Python programming. Okay. So these are the lines of code which you need to run, and you see something called as RC params, right? Parameters. This is an additional module which will help you tweak the plot style, the styling, look and feel of the plot, you can adjust a bit. So I'm going to run this block of code. And then you can read the CSV file. If you see pandas, we imported the pandas as PD. And we read it as pd.read_CSV. When you load it right within Python, if you're say loading a library called pandas, using which you can load the data, you can add additional columns to the existing data set, you can add more rows to the existing data set, so on and so forth. But if you don't want to use this as PD, as an example, what will happen? Here, when you read it, you need to write the complete name. You have to write it as pandas.read_CSV. You need to give that complete code. And this is challenging. Okay. So, not challenging. I mean, it'll be lengthy. Always you need to write the complete name. Instead, if you give a shortcut and say that I want to import pandas as PD, which is a shortcut, abbreviated format, then you can say pd.read_CSV, and within the single quotes, you give the complete path along with the name of the file and extension. So you have fish.csv. Okay, next. And this is the data set. If you say you are reading the CSV file and using the assignment operator, using equal to sign, you are assigning it to an object called df. In programming language sense, this is called as object. And this is read_CSV is called as a function. Once you load the data set into df, when you say df.head, you'll be able to see the first 5 rows of the data set. First 5 rows. There is some species of fish called as bream, weight of the fish. Then you have length along different directions, length of the fish. Then height, width, so on and so forth. Once you load the data, you need to perform exploratory data analysis and data visualization. We need to perform exploratory data analysis and data visualization. As part of exploratory data analysis, we are trying to figure out whether we have any null values. Null values means missing values. Suddenly some value might not be there here. Maybe some value is missing here. If you have that missing data, then you'll have null values. If you have missing data, you have to replace the missing values with some logical value. So, replacing missing values with some logical values is called as imputation. Okay. And when you look at this, you do not have any missing values in the data set. So all good, all hunky-dory, we can proceed further now. So the data preparation process became much easier because there are no missing values to deal with. Let us now do some more research, some more exploratory data analysis. So we are looking at the output variable. In this data set, the output variable that we want to predict is weight. What are the various input variables? You have species, you have length, all these lengths, you have height and width. All these x's are called as inputs. This y is called as output. This is the output that you want to achieve. So we are trying to visualize the variable called weight, which is the output variable. You're trying to come up with a figure which is going to have width of 12 units and height of 7 units. Length, some units are used to measure that. Okay. Then you're saying the title that you give here should be target variable weight distribution. Target variable is weight. You are trying to find out how the data are distributed. Size equal to 20. I mean, that's so you want the size to be bigger. Then you are giving label for x-axis, and you're saying that x-axis label should be weight and size should be 14. Here for this size is 20 and here size is 14. So this size is slightly smaller. Then you also have y-axis label, which is count. Then you're saying, help me plot a visualization called as histogram. Friends, one more thing. If you want to learn more about exploratory data analysis and all that, I've made it already available. Right? We have already made it available on our YouTube channel. You can please go to that and have a thorough understanding. And bins equal to 15. This is called as a bin. This is a bin. This is a bin. So all these are called as bins. This is one bin. This is one bin. This is one bin. These are all bins. And you want it in some color, some EC format. That is a font format. And then it appears like this. And when you have data like this, it is called as normal. This kind of distribution is called as normal distribution. If you cut it at the center, if the right side and left side are going to be symmetrical in nature, this is called as normal. But then here, it's appearing something like this. Like this. Okay, this is called as skewed. And if you look at the P from there, if you look at the right side, there is a long tail. Okay, this is called as right skew. Okay, this is right skewed data set. Okay. So that is what we understand from the data. Next, we are trying to use something else which is called as describe. All this aside, if you use this describe, okay, and if you do the analysis, for each and every species, it is going to give you information such as whitefish. So if you observe, there are a lot of species here. Okay. One species is called as bream, another is roach, one other is whitefish, so on and so forth. In total, how many bream fishes do we have in the data set? 35. In total, how many rows do you have? 20. What is the percentage in comparison to total? In total, how many observations do we have? Out of that 35 means what percentage? For example, if you have 100 observations in your data set, 10 out of these 100 say belong to a fish type called say whitefish. Then what is the percentage of total? 10 out of 100 means 10 by 100. And if you want to represent this in percentage terms, multiply with 100. So give you 10%. So 10% of this entire data set contains whitefish. Okay, that is what is given. And what is the rate of the bream fish? What is the average length? What is the average height, width? All that information is given. So average weight is 611.83 plus or minus 209.21. So if you subtract from 617.83, 209.21, what do you get here? 2, 6, whatever, 8 and 3. Okay. So you get 308.62, comma. If you add these two, because it is what plus or minus. So if you add this, you get 4, 828.04. Okay, so this is the range of the average weight that you can expect. In that way, you have all the, average length plus or minus some margin of error. Okay, that is what you got here. You can analyze each and everything and try to make out some sense from that. Then you can also do visualization. And here we are trying to use a library called as Seaborn. If I show it to you guys here. You have import Seaborn, which is an advanced visualization tool or library. You are importing that as SNS. When you say SNS.heatmap, it's giving you a heat map. And the color map here is given as blues. And you also have annotation. The title is correlation matrix. And the size of this should be 20. Figure should have 20 units along length and 9 units will be the height. That's it. You're trying to take your data set and trying to find the correlation. And this gives you correlation coefficient matrix. Along this diagonal, all the values are 1. Because this 1 is a correlation between weight and weight. Correlation between a variable onto itself will always be 1. Here, if you look at length, correlation between length 1 and 1 is 1. Right, so on and so forth. Now, if I cut it along the diagonal, the value that you are going to have here will be the same value here, 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 and here. All these will be the same values because this is a mirror image. For example, if you have 0.64, here also you will have 0.64. Here, if you have 0.63, here also 0.63. In short, this 0.92 is a correlation between weight and the length. 0.72 is a correlation between weight and height. 0.89 is a correlation between weight and width. In that way, whatever values appear, for example, this value is a correlation between length 2 and height. Next. we need to also ensure that as part of this data preparation, we convert the non-numeric variables. We convert the non-numeric variables into numeric. Why? Because if you cannot supply non-numeric values as is to your teapot, you cannot supply. Hence, what we do is we are going to convert non-numeric variables into numeric variables. What are the non-numeric variables? You have species. Species is the variable which is non-numeric in nature. You have various species, right? Such as roach, whitefish, so on and so forth. When you say pandas.get dummies, okay, and if you say I want to get the dummy variables of species, and then first I want to drop the species variable, and then create dummy variables of that. Right? And you're saying for every column, I want to prefix the column name with these. For example, if you have a column called as gender, okay, and if gender has male and female, in this way, you have the column. This is what non-numeric, it is categorical in format. If I supply this column as is to teapot, teapot will throw error. You say, I don't understand this. I only understand numbers. So what you are expected to do is convert this into dummy variable. And if you say get dummies, it will create dummy variable. That means it will create a column called male and another column called female. This row has male, so against male you put 1, female will be 0. This has female, so against female you put 1, male will be 0. Okay, next. If you say prefix equal to is, it will convert this column name as is underscore male, is underscore female. That is what has happened. So these are all the various levels of the column called species. Here, these two are the levels in a column called gender. So if I were to simply run this, 1 second. Huh? I think I haven't run the code right from here. Okay, anyways, I don't intend to run it, but let me run it. That's it. Then I need to, sorry, yesterday we mounted the data set. I need to once again mount this Google Drive. It will sometimes take permissions. Okay. Let it get imported, or let the Google Drive get mounted. Once the drive gets mounted, we can proceed further with further analysis. It's taking a while, but that's okay. It's worth waiting. Yeah, done. Google Drive is mounted. Now I can load the data set. You can check whether there are any null values or not. After loading, you have to do data pre-processing, data cleansing. And we are also doing data visualization. Then you have correlation coefficient matrix. So That's how it is, right? We have run it and we have the dummy. Now what you can do is you can import T-pod regressor. In the previous module, we have seen T-pod classifier. Here we are seeing something called as T-pod regressor. And from scikit-learn, which is a machine learning library, we are from model selection taking train test split. From scikit-learn, which is a machine learning library of Python, we are taking mean squared error and make scorer. And then you're writing your own function, which will calculate the root mean squared error. Done it. Why? Oh, no module name T-pod. So what I need to do is pip install T-pod. You might be wondering, in the previous module, we have already installed that. This is Google Colab, my dear friends. Each time you connect, Google is going to assign that server or that computer that is free on that, and that need not be the same thing which you have used yesterday. Google can assign you a different computer on cloud. So once again, you will have to install. There is no other. You've got install. I run this, which gives you the root mean squared error. I mean, you're just loading this function. Now what you're saying is, from the data set, let me segregate the inputs and output. So output is weight. You're saying drop only weight because that is output variable. Take remaining columns. Axis equal to 1 means columns. Okay, select this column, weight, drop it. And all the remaining columns apart from this weight will be part of X. And then your Y, which is nothing but the output variable. Then you're saying train test split X at 1. When you run this, you know how many observations you have in the training data and how many you have in the test data. 119 in training, 19 in test. Because you're splitting the data in the ratio of 25% test and 75% training. Okay. And you also have something called as random state. I'm getting tempted to explain this. Okay, let me explain because anyways, I'm training already. So within a data set in Python, you have various columns and there's one column called weight. If you want to refer, and this entire data set is stored in an object called df. If you want to refer to any column in Python, you either say df dot weight, or you can also write it as df of single quotes weight. This will also ensure that you refer to this column. You can also put this in double quotes, doesn't matter. Single quotes or double quotes, doesn't matter. Okay. So that's how you refer to the columns. Next. If you have a data set, and if you split this into training data and test data, suppose you have a data set which has an output variable and input variables, and say you have 10,000 observations. Say you're randomly splitting the data as 75% into training and 25% into test. So what happens is, since you're randomly splitting the data, that is how you need to split, by the way. Random split only is recommended, just to ensure there is no bias. Okay. Then you will have 7,500 observations in your data set. You have your output variable and your input variables. and you have 7,500 observations. Because 75% of 10,000 is 7,500. And all these are randomly chosen. Observations are randomly chosen. So, say the first observation is 2, next is 3, next is 5, next 7. So 1, 2, 3, 4. If you count overall, you will have 7,500. If you look at the observations, it is randomly, observations are randomly chosen into training. And then remaining data will be part of test. So you have your output variable and input variables. Output and input. Observation number 1 is missing, so it will be here. Observation 2 is there, 3 is here, 4 is not here. 5 is there, 6 is not here, so on and so forth. If you count overall, you'll have 2,500 observations. Why 2,500? 25% of 10,000. Now after this, you build your model. You build your machine learning algorithm. What do you mean by building machine learning algorithm? Learning the patterns in the data. Learning the patterns between output variable and input variables. Your model is going to learn the patterns. And after it learns the patterns, it is going to, sorry. After the model learns the patterns, it is going to capture the patterns in using some math equation, some mathematical equation. Say you use some regression technique, so you will get an equation like this. Beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. If you're using some regression analysis, there is a machine learning algorithm called as regression analysis. If you use that, you get an equation like this. Next. After you build your model like this, which will learn the patterns, you cannot say that customer, I've built a model, take it and use it. You cannot say that. Instead, what should you do? Instead, you have to test your model on the test data. When you test your model in the test data, maybe you get a test accuracy of, you got a test accuracy of say 80%. But maybe customer says, until and unless you give me 90% accuracy, I'll not accept. So what will you do then? With this information that you got 80% accuracy, you go back and change your hyperparameters. Hyperparameters are options which can be changed to experiment your model. So that is also called as tuning the hyperparameters. Okay, it's called as hyperparameter tuning. That means you change, tweak the hyperparameters. And then again build your model, again test it. This time say you got test accuracy of 85%. Still you're not happy. Again go back. Again tweak your hyperparameters. Again test your model on the test data. And then maybe you will get an accuracy of 90%. Say now you're happy. But then, if you are looking at these three models, using model 1, you got this accuracy. Using model 2, you got this accuracy. Using model 3, you got this accuracy. When can I compare these three models when these three models are built on the same data and tested on the same data set. This is something like this. Say you have three students. Student 1 got 80%. Student 2 got 85%. And say student 3 got 90%. Now, which student got highest marks? Student 3. You can say this only if all these three students have studied on the same subject, same syllabus. Maybe student 1 studied on state syllabus. Student 2 studied on central syllabus, federal syllabus. Student 3 studied some kind of international syllabus. Then you cannot compare these three students and say that student 3 got highest marks. Maybe state syllabus is very tough, so students tend to get less marks. International syllabus is slightly easier, so students tend to get more marks. Who knows? Maybe. So you cannot compare. When can you compare these three? Only when all the students have probably prepared on, say, state syllabus. All three. Then you can compare. Apples to apples comparison can happen. On similar lines, even during your machine learning building process, only if all these three models are built on the same data and tested on the same data, only then can you compare the results. And when you look at lines of code, what do you do first? You load the data set. Then you do data cleansing. Then you split the data. Then what do? You split the data into training and test. Then you build your model. You build your model on the training data, right? And then you test your model or evaluate your model on the test data. These will be the lines of code. So, first time if you get 80%, if you're not happy, you go back and tune your hyperparameters, which happens here in the building model phase. You also tweak your hyperparameters. And then you test your model that you built. But sometimes what happens is you might make the change here in this line. You might change the hyperparameters. And you'll have an option to run the entire file. You might click on that option. You might, in hurry or accidentally, or most people do this, so you might click. If you click, what happens? It will again load the data, clean the data. Again, it is going to randomly split the data and then build the model on the new parameters. If it is going to randomly split the data, you'll get different data in training and different data in test. But that is not what we want. Each time we split the data, I want same observations like 2, 3, 5, 7, etc. in training. And I also want same observations in test 1, 4, 6, etc. To ensure that you give an additional parameter called as random state. You mentioned something called as random state. And within the brackets, you can give any number. Here we give 42. You can give 1, 2, 3, 4, 5, whatever you want. This number, the moment you give random state, as soon as it splits the data, it records all these observations at observation 2, 3, 5, 7, etc. is part of training. Observations 1, 4, 6, etc. is part of this. It will store that information in this way. Then when it splits, it knows that since 4 has this information, that all these rows should be part of training. All these rows should be part of test. It will split accordingly. So you'll have this exact same data even for model. That is the reason why people use random state, just to ensure that anytime you split the data, the same data stays in training and same data on test. So you can run those basically, and then you can just try out linear regression, right? So if you try running linear regression, run the model from scikit-learn, import linear regression, store linear regression default values as is, default hyperparameters as is. Then when you say lm.fit, you store the model in lm. When you say lm.fit of training inputs and training output, whenever you want to build the model, you need both output and inputs. Once you fit this model, you can use that model to predict on the test data and store the predicted values in this, and then find out error, root mean squared error, by giving your actual values and predicted values. You get 82.107. Then we will look at a teapot model. If I run a simple linear regression, I got root mean squared error of 82.1. However, if now, look at this, make scorer, you are saying root mean squared error, greater is better is false, because is error more better or less better? Error lesser the better. Obviously, right? You want error lesser the better. So that is what we are saying here. Greater is better is false. Lower is better because it's a stored. And you're saying, I want to run teapot regressor. The scoring value will be root mean squared error. Maximum time will take 10 minutes. Random state is given. Verbosity 2 means it will give more information. And then you're storing that in pipeline optimizer. And you're saying pipeline optimizer dot fit. The moment you click on dot fit, it will run the teapot regressor. Whenever you fit, you need to have inputs and output. When you run this, look at what has happened. It has tried out various cross-validation scores and it has stopped prematurely. Teapot closed premature. Look at its score, friends. Here you are getting error of 82. Here you are getting some negative values. Right? So error is very less. Okay, that is what it means basically. And when you say, all right, what is the best pipeline? It says rich cross-validation technique. But first apply AdaBoost regressor by taking polynomial features, then random forest regressor. What not it has tried out? It has tried out a different pipeline altogether. But then, when you look at this, print the pipeline optimizer score, means what are you saying? Use this optimal pipeline that we have built and score it, predict on the test data. When you do this on the test data, you get the result as -6. Forget about minus sign here. For some reason it's appearing. I don't want to get into that explanation, but forget about minus. You're getting 65. 65 is the root mean squared error. Here you got 82. If you use linear regression as is, you got 82. But the error significantly reduced when you use teapot. That too, we have run this algorithm only for 10 minutes. If you run it for 1 hour, 2 hours, etc., you'll get the best pipeline. And what do you do after that? Show me the pipeline. When you type it, it's showing you this incomplete pipeline. Very big pipeline is what it has come up with. Then you can export this pipeline, fish underscore pipeline. You export it and store it so that you use it for future purpose. So let me now. I think it will take some time for me to run it. But then once you store this in your drive, you can use it for future purpose. Okay, this is how you typically build your teapot model. So just to do a recap, teapot is something which can be used for regression purpose. That is when your output variable is numerical. And you can also use teapot for classification purpose. That is when your output variable is non-numerical. Okay, both for numerical purpose and non-numerical purpose, we use teapot. Okay, next. For this, we use simply put teapot dot regression, and for this we use teapot dot classifier. Okay, that's a thin line of difference, right? There is nothing sacrosanct about it. This is what. Okay. Or you just say teapot classifier. However you want to import that. It's up to you on whether you want to give a uppercase or lowercase, etc. However you import, in that way you have to deal with it. Okay. So that's how you build the model, friends. And let me tell you on what we are going to do in the next module. In the next module, when we connect, we are going to talk about parallel processing, parallel training, and we use a library called as Dask library. And once this is done, we look at teapot model deployment. How do you deploy your model in production? Next, how do you monitor the teapot model? Monitor. These are the things we'll do. With that, the entire pipeline will be complete. We'll keep it aside. Then we'll move to the next set of things, which includes feature tools. We'll just look at a glimpse when it comes to feature tools. Then we'll get into cloud-based machine learning or cloud-based auto ML concepts. Okay. So thank you all so much, friends, once again for joining. And quiz question is posted on the chat window. Please click on that and please take the quiz question. And I'm sure you all will love that quiz question. Thank you all once again for your patience. We'll connect in the next module and take this discussion further. Thank you.